Have you ever wondered how computers in the same vicinity communicate with each other? This seemingly mundane phenomenon is driven by an intricate system known as a local area network, or LAN for short. The concept of LAN is a cornerstone of modern computing. It's a network that connects computers and other devices in a relatively small area, such as a home, school, or office building. The main purpose of a LAN? To facilitate communication between devices, allowing them to share resources and information swiftly and securely. Let's start with the basics. What do you need to set up a LAN? First, you need computers. These can be desktops, laptops, or even mobile devices. Each computer in a LAN is known as a node. Next, every node needs a network interface card, or NIC. This card serves as the liaison between the computer and the network, translating the data from the computer into a format that can be transmitted over the network. Then comes the switch. Imagine a busy intersection in a city. The switch is like the traffic light, controlling the flow of data across the network. It ensures that information from one computer reaches the correct destination without colliding with data from other computers. Routers are another key component. They act like postmasters, directing data packets to their correct destinations, either within the LAN or to another network like the internet. Finally, you need cabling. This is the physical medium that connects all the components of the LAN together. It could be copper wires, fiber optic cables, or even wireless signals. The choice of cabling can greatly impact the speed and performance of the network. So there you have it, the basic components of a LAN: computers, network interface cards, switches, routers, and cabling. Each plays a crucial role in enabling communication between devices in a localized area. Now, you grasp the basics of a LAN, but how does it work? Let's dive deeper. The architecture of a LAN has a lot to do with how it operates. When we think about architecture, we usually think about buildings, bridges, or cities. But here, we're talking about the structure of a network, specifically a local area network, or LAN. This network architecture dictates how devices communicate and how data moves within the system. One of the most common types of LAN architecture is known as the star topology. Picture a star in your mind. At the center you have a central device like a switch or a hub. This is the heart of our star, the core of the network. From this central point, connections radiate outwards to all the other devices on the network, much like the points of a star. Every computer, every printer, every scanner, every device that's part of the network is connected to this central hub. It's a simple, effective structure that allows data to flow smoothly from one point to another. But how does it actually work? Well, when a device wants to send data to another device, it sends the information to the switch. The switch, in turn, directs that data to the correct device. It's kind of like a traffic cop, managing the flow of data, making sure everything gets where it's supposed to go. Just imagine the chaos if there was no central control. Data would be flying around aimlessly, clogging up the network, causing delays and errors. But with the switch at the center, directing traffic, everything runs smoothly. Now, it's important to note that the switch doesn't just passively direct data. It also manages the data flow, prioritizing certain types of data over others, and preventing data collisions. It's a bit like a conductor leading an orchestra, ensuring that each instrument plays at the right time to create a harmonious symphony of data. That's the power of the star topology in LAN architecture. It's simple, it's efficient, and it's effective. And at the heart of it all, the switch serves as the conductor, orchestrating the communication within the network. Every conversation needs a language, and computers are no different. Just like humans use languages to communicate, computers use protocols. These protocols are sets of rules that dictate how data is sent, received, and interpreted between devices. An essential part of this communication on a local area network, or LAN, is the Transmission Control Protocol, Internet Protocol, often shortened to TCP/IP. TCP/IP is like the foundation of a house. It forms the basis on which all other elements of the network are built and function. It's a suite of protocols, each with a specific job, working together to ensure data is delivered correctly and efficiently. The Transmission Control Protocol, or TCP, breaks down the data into smaller packets, checks for errors, and ensures each packet is delivered to the correct destination. Meanwhile, the Internet Protocol, or IP, is responsible for addressing and routing these packets. Now imagine you're at a party with lots of people. You need a way to identify each person, right? This is where IP addresses and MAC addresses come into play in a LAN. An IP address is like a person's name at the party. It's a unique identifier for each device on the network. When data is sent over the network, it's packaged with the IP addresses of both the sender and the receiver. On the other hand, a MAC address is akin to a person's physical features. It's a unique identifier physically assigned to each network interface card by the manufacturer. While IP addresses can change, MAC addresses are permanent. They help to route data packets to the correct device on a local network. So, to sum up, computers on a LAN communicate using a sophisticated language of protocols, primarily TCP/IP. They identify each other using IP and MAC addresses, ensuring the data reaches the correct destination. Think of these protocols as the grammar and vocabulary of computer networking. Servers play a pivotal role in a LAN, acting like the network's librarians. They're the unsung heroes of the network, diligently working behind the scenes to keep the digital world turning. Let's break it down a bit. In a LAN, there are several types of servers, each with a unique role. First up is the file server. Think of it as a colossal storage box, storing and managing the data files that make up the digital lifeblood of your network. It's the go-to place for your documents, spreadsheets, presentations, and more. Next, we have the print server. This server is the maestro orchestrating all the printing tasks in the network. It queues print jobs, manages printer resources, and ensures that your 50-page report doesn't end up in someone else's print tray. Mail servers are like the post office of your LAN. They handle the sending, receiving, and storing of emails. It's these servers that ensure your crucial email reaches its destination swiftly and securely. Last but certainly not least, we have the web servers. These are the servers that host websites and allow you to access them over the internet. They're the reason you can read the latest news, do your online shopping, or binge-watch your favorite series. Each of these servers provides a different service, but they all have one key thing in common. They're all about providing the right resources to the right users at the right time. They manage resources, control access, and ensure that everything runs smoothly. Without them, a LAN would be like a city without traffic lights, a chaos of data with no direction. So the next time you print a document, send an email, or access a website, spare a thought for the servers. They're the silent, tireless workers that make it all possible. Servers ensure the right resources get to the right users at the right time. Local area networks may seem complex, but they follow a logical structure. We've journeyed together through the intricate workings of these systems, unraveling the threads that hold our digital world together. We started our exploration with a deep dive into what a local area network, or LAN, actually is. We learned that it's a network that connects computers and other devices in a limited area such as a home, school, or office building. By facilitating data exchanges, LANs form the backbone of our day-to-day digital interactions, from file transfers to video conferencing. Next, we demystified the architecture of LANs. We discovered that they're structured in a way that allows for efficient communication between devices. We looked at how this architecture includes elements like Ethernet cables, switches, and routers, each playing a pivotal role in transmitting information. Then we investigated how computers communicate on a LAN. We learned that when you click send on that email or hit print, your computer sends a data packet through the network to its destination. This process involves a series of handshakes and verifications, ensuring that data reaches its intended recipient securely and accurately. Finally, we examined the role of servers within a LAN. We realized that servers are the unsung heroes, quietly facilitating our data needs. From the Active Directory that manages our user access, to the web servers that host our favorite sites, and the email servers that handle our correspondences, they all play a part in making our digital life possible. In essence, LANs are an intricate ballet of data swirling invisibly around us. Every email sent, every document printed, every web page accessed, is a result of this complex yet orchestrated dance. It's a dance choreographed by the architecture of the LAN, performed by the computers and servers, and made possible by the rules of digital communication. Next time you send an email or print a document, you'll know a bit more about the intricate dance happening behind the scenes. Before we wrap up, let's take a moment to appreciate the grandeur of this dance of data. Every click, every keystroke, every digital interaction we make is a part of this intricate ballet. It's a dance that's constantly evolving, adapting to new technologies and trends, and it's a dance that we're all a part of. Whether you're a casual internet user or a seasoned IT professional, the LAN is a part of your digital life. So, the next time you send an email, print a document, or simply browse the web, remember the steps of this dance. Remember the architecture that choreographs it, the servers that facilitate it, and the data packets that perform it. And know that you, too, are a part of this grand performance. If you found this video helpful, don't forget to subscribe to our channel for more deep dives into the world of technology. And remember, the dance of data never stops. So, keep learning, keep exploring, and keep dancing. Until next time, stay connected.